All right, quick video on how to go from a graph to creating your own piecewise function. So hopefully you've watched my prior video on piecewise functions because I'm going to be referring to some terminology I use in that. You'll notice this one is a little different than the one we did in the video. This one has 3 different behaviors. Doesn't matter, we're going to use the same principles. Let's get it. So the first thing I look for is the walls. Where does the change in behavior occur? So I'm going to set it up with function notation, just f of x equals. You'll notice we have 3 different behaviors, which means I'm going to have 3 different descriptions of where my different behaviors are occurring. So this first one, it's got everything covered from the left all the way up to, there's our first wall. Well, that first wall is at the x value of 1. So if all of this behavior is happening before 1 and it's an open circle, that means that this first behavior exists when x is less than 1. Okay? All of this exists prior to x being 1, and it's an open circle, so it's not included. Now, this little blip on the radar has a starting and a stopping point, which means our x is going to be greater than a certain value and then have to stop when it's less than a certain value. And what values does that lie between? Well, it takes the handoff from the first behavior, so we know it has to be larger than 1, and then it stops and hands it off to the next person or function at 2. Now, I'm missing something though. Notice your circles here. Both are closed, which means we are equal to in both of those behaviors. And lastly, last behavior takes the baton and runs with it, doesn't stop. So that means this exists anything beyond 2. Okay? So that's just deciding where my walls occur. Now I need to define the behaviors in each of those sections. So this first one is pretty nice. We like looking at equations of lines because we can revert back to y equals mx plus b slope-intercept form. So all I need is my m and my b. There's a y-intercept of 3. And you'll notice the slope is up 2 over 1. So this line has a slope of 2 and an intercept of 3. So my very first behavior is 2x plus 3. Isn't that nice? Don't overcomplicate it. What did you need? A slope and an intercept. And this line gave you both of those. Okay? Now, the second one, this is the hardest part, so make sure you're with me on this. It does have a slope. You can see that slope, it goes down 1, right 1. So this has a slope of -1. But how do you find an intercept if it doesn't technically intercept? Extend the line. If this keeps going with that slope, it would hit right here at 2. That is your y-intercept. So again, in this little blip, even though it's this tiny piece, you can still find the slope and the y-intercept. Slope is just how you get from one point to the next. The y-intercept, you may have to extend it to find where it would cross. That's okay. So again, I use my slope, -x plus 2. Notice all I'm doing is taking an m and a b and plugging it into slope-intercept form. This last one freaks you guys out, and it's the easiest one. Horizontal line. A horizontal line has a slope of 0, meaning all it is the y value that is continuous. We'll take a look. This is just going to run continuous 3. That's it. That is the equation of a horizontal line. It's the y value that it continuously goes through. So, quick tutorial on how to interpret a graph of a piecewise function. Find your walls to create your inequalities. Find the behavior of each piece to create your equation. That's it.